Welcome back, dear students. Today we are going to have lesson 2, solve inequalities using addition and subtraction. Okay, the solution of any inequality is a set of values that make the inequality true. Values that are not in the solution set will make the inequality false. You can use inverse operations to solve inequalities in the same way you solve the equations. Remember, when you add or subtract the same number from both sides of an inequality, the inequality remains true. So here what should we do? I have here an inequality 3 less than 5. 3 less than 5 is a true inequality. Add 2 to each side. Okay, 3 plus 2, and here 5 plus 2. So I have here 3 plus 2, 5. 5 plus 2, 7. So here 5 is less than 7. Remains true inequality. If I subtract 2 from each side, 3 minus 2, 3 here minus 2 equals 1. 5 here minus 2 equals 3. So it remains true inequalities. Okay, I have here example 1. Determine whether x equals 6 is a solution for the inequality x plus 4 less than 15 or not. Test whether x equals 6. How? By substituting here for x, I will write, instead of x, I'll write what? Yeah, 6. 6 plus 4 equals 10. So here 10 less than 15 is a true inequality. Yeah, it makes sense. So here the steps I have here, x plus 4 less than 15. We replace x with 6. Okay, instead of x I put here 6. 6 plus 4 is less than 15. True or false? Of course, because 6 plus 4 equals 10, and 10 is less than 15, right? So 6 is a part of the solution set for the inequality because it makes the statement what? True, right? Example 2. Good morning, everybody. Are you awake? Let's complete. Determine whether x equal 15 is a solution for the inequality x minus 10 greater than or equals to 28. I do what? Substitute x for 15. Replace x and put instead of it 15. Okay, 15 minus 10 less than or equal 28. Then 15 minus 10, make the subtraction, so the answer will be 5, right? 5 is greater than or equal 28. Do you think this is a true statement? Is 5 is greater than or equal 28? Of course not. So the statement is false. Okay, f is not greater than or equal to 28, so 15 is not part of the solution set. Here I have an example. Determine whether each value for c is part of the solution set. Right? Yes or no? Here I have 8.6 and I have here the inequality c plus 3 less than 8.6. Instead of c, here are the values given in the table. 8.6, I write here 8.6 plus 3 less than 8.6. Is this true? Of course not. I have here c, instead of c I will write 8.6 plus 3 all greater than 8.6? Of course, yes. Okay, and here c plus 3 less than or equals to 8.6. Here I put 8.6 plus 3 less than 8.6. Of course not. And here 8.6 plus 3 greater than or equals to 8.6. The answer is of course yes. Moving to the other slide. Okay, here I will enlarge for you to see it well. Okay, it's clear now. Solve x plus 5 all less than 26. Okay, follow the same steps to solve an addition or subtraction inequality as you would with an addition or subtraction equation. An inequality will have a set of solutions. I have here inequality and equation, related equation. X plus 5 less than 26. We can treat this as equation. X plus 5 equal 26. Okay, instead of less than I put here equal. Okay, x plus 5 equal 26. How can I get x, the value of x alone? So I have to remove positive 5. How can I remove positive 5? Okay, the opposite of positive 5, negative 5. So I'll add here negative 5 and here negative 5. So here x plus 5 minus 5, 26 minus 5. When I add here negative 5, I have to add here the same negative 5. So here x is alone equals 26 minus 5, 21. I can do the same here in the inequality. X plus 5 less than 26. I want to get rid or remove the positive 5, so I'll add negative 5. Positive 5 minus negative 5 will give me 0. So x will be alone, and 26 minus 5, 21. So x less than 21. All values of x that are less than 21 make the inequality true, because x is less than 21. The solution set is what? All rational numbers less than 21. All rational numbers less than 21. Example 5. I have here solve x minus 12 greater than 8. So I want to get rid of negative 12. So I will add positive 12. Look here. When I add here positive 12, I have to add in the other side the same number, positive 12. So x will be 8 plus 12, 20. So the solution is all rational numbers that are greater than 20. Now, example 6. Solve x plus 5 less than or equals to 19. Graph the solution set on a number line. It's very easy. X plus 5 less than or equal to 19. What should I do then? I here want the x to be alone. So x here, I should do what? The opposite of positive 5. Yeah, I can hear you. Negative 5. So x will be less than or equals to 19 minus 5 equals 14. Here, focus with me. Open your eyes. Yeah. I have here x less than or equals to 14. Here I put a circle, open or closed, as I told you in the last session. Yeah, closed. Why closed, miss? I want to remember, because here I have or equals to. So here I put closed circle. Okay? X is less than or greater than 14, less than. So I will move to the left side to 13, 12, 11 and so on. It's easy now? I think so. Example 7. Solve the inequality x minus 6 all less than greater than 2. Graph the solution set on a number line. X minus 6 greater than 2. I want x to be alone, so I want to get rid of, remove negative 6. How can I remove it? By adding positive 6, the opposite of negative 6. So x will be alone, and here when I added positive 6, I must add here positive 6. So x is greater than 8. The answer will be 8. Okay, when I put it on the number line, remember, here I have greater than without equals to. I put it open, right, open, greater than, then I go to the right side after 8, 9, 10, and so on. It's easy now. Okay. In the